installing some software somewhere. All right. So we're going to talk law of sines and law of cosines today. You should have watched a video yesterday, a Khan Academy video. We don't know what happened to our video that we had made, so we'll have to re-record that for next year, even though I think we said that last year too, but you know, it happens. We're old, we can't remember everything.
Speak for yourself. Oh, wait, no, that's not me.
I think that's the one.
Nothing downstairs.
Oh, okay. Good to know. Okay. So what we are going to do then is we're going to talk law of sines and law of cosines. Now you've been introduced to them back when you were in geometry. Okay? And so either of them allows us to solve non-right triangles. Okay? So we have toolbox items, tools in our toolbox for right triangles. SOHCAHTOA, Pythagorean theorem. We can use the law of sines and we can use the law of cosines in right triangles, but we don't need to because we got SOHCAHTOA. It's much easier. Okay? But for non-right triangles, we only have the law of sines and the law of cosines. Okay? And so we're going to work on that today. So we'll be in your green packet that you got, if you were at home, you got last week. If you are, those of you in the room, you just got it today. We'll actually be working off of the first two sides, maybe even the first three sides. Okay, right? So, or I should say, the first five sides. Okay, but we'll follow along as we go through. Okay, so here we go. Again, make sure you have a calculator. Okay, so first off. The video that we had wanted to show you would have taken you through the top half here of the first green sheet and how the law of sines is derived. And the law of sines is actually derived from the area formula of a triangle. Okay? And so if you have, you know, with the height and all that stuff, anywho, what it boils down to is you have the law of sines. Okay? And the law of sines says that if you take the sine of angle A in your triangle and divide it by side A. Now thinking back to a triangle, okay? So we're thinking back to a triangle. If this is angle A, then the opposite side is side A. Okay? So the sine value for that angle divided by its opposite side is equal to the sine of that angle divided by side B is equal to the sine of this angle divided by that side. Okay? So that's what the law of sines says. In order to use the law of sines, this is very important. In order to use it, we must have one complete fraction. So we have to have at least one angle and its opposite side. Okay? If you don't have one angle and its opposite side, then you've got to use something else. Okay? If you're in a right triangle, you could use Pythagorean theorem or SOHCAHTOA. If you're in a non-right triangle, then you'd have to use law of cosines, okay? Which we'll get to later on today. Okay? Fantastic. So we're through the front side of the first page. All right? Let's dive right into it. This is example number 1, top of page number 2. Okay? So it says solve the triangle. Solving the triangle means we need to find all of the missing angles and all of the missing sides. Okay? All right? So you can draw yourself any old triangle. Move this all over here so that we get it nice and pretty. So if I say that this is angle A, and any of the three angles can be your angle A, okay? Angle A is 48 degrees. Angle C is 62 degrees. And side A is 16. So we'd have some kind of a setup with our triangle like that. Again, doesn't matter which angles you have as long as you have 48 degrees being opposite of side 16. That works for me. So we need to find, the things that we need to find are angle B, side C, and side B. Anybody have an idea how we can find one of those? Lexi, I saw your hand first. Measure angle B. And refresh my memory, the three angles of a triangle need to add up to be 180 degrees. Exactly. So if we said 48 degrees plus 62 degrees plus angle B has to be 180 degrees. So that is 110. Yep, 110. Is 180. So I get angle B has to be 70 degrees. Agree? Love it. One of our answers. We need three of them, though, because we need to find side B and side C. Okay? Then, now, let's use the law of sines. So the sine of 48 degrees divided by 16, sine of angle A divided by side A, has to equal the sine of angle B, which is 70 degrees, over side B. We'll keep it at that one for right now. Okay. How would we go about solving the green fraction? Cross multiply. Exactly. So we get B times the sine of 48 degrees is equal to 16 times the sine of 70 degrees. I like to do all of my math written out before I go to my calculator. So we would divide both sides by the sine of 48 degrees. And when we do that, if you could do that, please, right now on your own individual calculators, just so that we can see if we have everything that we need to have and we know how to punch things in. I get here that side B is 20.231. Speak now if you did not get 20.2317. At home, also, unmute yourself, because I need to know what kind of calculator you have so that I can figure out where we went wrong. All good so far at homers? Okay. All right. Then, so we found side B. Now we've got to find side C. So again, we would have the sine of 48 degrees divided by 16. I would use that one as opposed to using side B and angle B. Because you rounded probably when you wrote down side B, and the other two give you exact values. That. We would follow roughly the same pattern. Side C times the sine of 48 degrees equals 16 times the sine of 62. I get 19. And those three answers, along with the original three things that you were given, solve our triangle for us. Yes? Love it. Yeah? So, what I would like you to do now is I would like you to attempt this particular problem, which is number 2, in your green packet. Minutes. Side B is 4. C is 61 degrees and 20 minutes. Okay. So 24 degrees 10 minutes plus 61 degrees 20 minutes plus angle A has to equal 180 degrees. So that would be 85 degrees 30 minutes. So angle A here is going to have 30 minutes into it, right? That gets me to 86 degrees. 4 gets me to 90. 90 more gets me to 180. So I get 94 degrees, 30 minutes for angle A. So then the sine of 24 degrees 10 minutes divided by the side of 4 is going to equal we'll go with the sine of 61 degrees 20 minutes all over side C. C times that is going to be 4 times that. Side C is going to be 4 sines of 61 degrees 20 minutes divided by the sine of 94 degrees, 10 minutes, which is, I think, bring this over, maybe. Okay, there we go. Now we can see it all. So this would be 4 times the sine of 61 degrees, 20 minutes, divided by the sine of 24 degrees, 10 minutes. And I get 8.57295. Now can I go away? 8.57295. 8.57295. Then top sine of 24 degrees 10 minutes over 4 is going to equal the sine of 94 degrees minutes all over side A. A is going to equal, that would be 4 sine of 94 degrees minutes divided by that. Top, this back. Yeah. Up higher. Oh, I guess I gotta go all the way over. Oh well. So we can bring that back, and the only thing that's going to change is 94 30. 9.74046. Agree? Love it. Love it. Questions, comments, concerns, clarifications? Seeing none. Example number 3 on that page. This is an example that we would like you to do on your own. Not right now, because we're going to go on to the law of cosines now. So we can do that after we're done with notes today. You can come back to that. Okay? So, law of cosines. This is the proof of the law of cosines. Okay? It's spelled out for you on the top of the law of cosines page in the green packet. Okay? It's derived from the distance formula. Okay? Law of sines is derived from the area formula. Law of cosines is derived from the distance formula between points B and C. Okay? If you want, later on I can go through that more for you. Just know that this pattern repeats itself when depending upon what you have. So yes, a squared is equal to b squared plus c squared minus 2 times b times the cosine of a, but also that b squared is equal to a squared plus c squared minus 2ac cosine of b is the second law of cosines. C squared is equal to a squared plus b squared minus 2ab cosine of c. Okay? Don't necessarily waste your time on the actual law of cosines. Memorize the pattern. Okay? It's always Pythagorean theorem, a squared plus b squared equals c squared, or a squared plus c squared equals b squared, or whatever. It's the Pythagorean theorem part, and then it's minus 2 times each of those sides individually times the cosine of the angle. Yeah? Love it. So, utilizing the law of cosines, this is going to be useful for you when you have when you don't have an angle and its opposite side. Okay? So that's when we would use the law of cosines. So I would start by drawing yourself a picture of any old triangle. Okay? Filling in your values just like we did before. A is 35 degrees. We'll call this B, and we'll call this C. So then side B would be 15, and side C would be 30. Okay. This is a side angle side case, which is the law of cosines, because I don't have what side A is. This is a non-right triangle, so I can't find what side A is using the Pythagorean theorem. So we have to use the law of cosine. In this particular case, I would use a squared is equal to b squared plus c squared minus 2bc cosine of angle A. So that is going to be 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 35 degrees. Get all that typed in on your calculator. 15 squared, 30 squared, minus 2 times 15 times 30 times cosine now of 35 degrees. And I get that this is approximately 387.763 on my calculator. Okay. but I'm not going to do anything with it because that's a squared. So a then is going to be the square root of that. Using the answer key on my calculator, I get a here is 19.6917. Leave that on your calculator and set your calculator aside because we want to keep that as the answer on our calculator so we can use that going forward. Okay? Yes, ma'am. I 15 squared plus 30 squared minus 2 times 15 times 30 times the cosine of 35 degrees. Yeah, no, I got 387. Okay? So, proper mode of your calculator, knowing what mode your calculator is in. Okay? In the past, we've got a bunch of calculators in the back that we would use, and all of those are in radians. So then that's where people would screw up using this because this is in degrees and those are in radians. But yeah, proper mode. Okay? So leave that on your calculator for you. Once you use the law of cosines once, you don't have to use it again. Okay? You only got to use the law of cosines once because now you have a complete fraction. So we can say then that the sine of 35 degrees divided by, and I'm going to put it in blue because it's on my calculator and I'm not going to round it, is equal to the sine of angle B divided by 15. So A times the sine of angle B is going to equal 15 times the sine of 35 degrees. I'm solving for angle B here. Now, here is where keeping it on your calculator helps. Okay? I need to know what this fraction is. So I am going to go 15 on my calculator, provided that I can see what I'm typing in. I'm going to go 15 times the sine of 35 degrees divided by my answer. And there should be an A and S key on your calculator somewhere. Usually on the TI-30Xs, the most popular calculator, it is the second of the negative key, way down at the bottom. It should say A and S on it. Okay? So you get that fraction. Then you have to take the inverse sine of that. Okay? And I get angle B here is 25.9074 degrees. angle C is going to be angle A, which was 35 degrees. Oops, excuse me. I'll put it in a different way because I think there's 180 degrees in the triangle. So it's 180 degrees minus 35 degrees minus that. So I get angle C here is 119. Point 09 degrees. The less you round, the more things that you leave on your calculator exactly, the better. Okay? The better. Or if you do round, the more decimal places you round to, the closer you'll get to them. Okay? Love it. So this example here, number 2 on the back side of the law of cosine sheet, that again is an example that you guys can do after we're done with the notes for today. Okay? So that leaves us with the side case. So we've done angle side, or excuse me, side, angle, side, side is what's left over. Okay? So when you're solving for an angle using the law of cosines, okay? So I want to get here now cosine of A. I want to get that by itself on its side so we can use inverse cosine. So the first thing that I would do here is I would subtract B squared and C squared from both sides. So that's going to give me A squared minus B squared minus C squared is equal to negative 2 BC cosine of A. Then I would have to divide by negative 2 BC on both sides. That's going to give me cosine of A is equal to that fraction but that fraction is also that. If I multiply the top by negative 1. If I move the negative sign from the bottom to the top, we get that. So angle A here would be equal to the inverse cosine of that. The same pattern would hold angle B would be the inverse cosine of, so we went A, and the other two are being added. So then we would have A squared plus C squared minus B squared all over 2AC would be the other one. Angle C would be the inverse cosine of, so we're solving for C, so then that would be A squared plus B squared minus C squared all over 2AB. Now, here is the most important part of both laws of sines and the law of cosine. Is that, oh no, where is it? When you're using the law of cosines and you have to find an angle, you need to find the largest angle first. Okay? Write that down somewhere on your paper. Law of cosines, find the biggest angle first. When you're using the law of sines, it's reversed, or it's opposite. You want to find the smallest angle first. Okay? So law of cosines, it's how I remember it, the law of cosines is a larger formula to use, so I need to find the largest angle. The law of sines is a smaller, more compact formula, so I want to find the smaller angle first. The reason for that is because back before Christmas, I believe, we were finding the law of sines. We were looking here in the right half of the unit circle. We were looking in quadrant 1 and quadrant 4 for our angles. Well, quadrant 4 are negative angle values, right? In a triangle, can we have negative angle values? No. So that takes away quadrant 4. So all of the law of sines gives us is acute angles. Those are the smaller ones. So that's why we go with acute angles there. Why to keep it going black, just let it slide. Okay? So that's why we go small when we're using law of sines. Law of cosines, we were looking at quadrant 1 and quadrant 2 to find those. Both of those are positive, and so that's why we find the biggest one first, because it takes away finding the smaller one. Okay? So biggest when we're using law of cosines, smallest when we're using law of sines. Okay? So let's jump into, this is example number 3, now at the bottom of that page. Okay? Does anyone remember, if I drew this triangle, and I said 3, 5, and 6, so then that would be, angle A would be here, angle B would be here, and angle C would be there. Based off of the side lengths of a triangle, which angle is the biggest? What you got? A? Do we agree that angle A is the biggest? You don't got a lot of support from your classmates. Anybody have a different guess? C? Okay, why do you think A and why do you think C? Which one wants to go first? Because it goes across the biggest, the longest side. Okay, what are you thinking A? How many obtuse angles can we have in a triangle? Only one. You only have one. Okay? So, what does it say there? Yep. So we don't want to find A then first, because we want to find the biggest one, right? Okay. So we want to find the bigger one. So I'm going to go with what Max said. We're going to go with angle C first. Okay. Because side C, biggest side, angle C, biggest angle. Okay. That's that relationship in a triangle. Biggest angle is opposite the largest side or the longest side. Smallest angle is opposite the smallest side. Okay? So here we go. We're going to find angle C first. So angle C is going to be the inverse cosine of A squared plus B squared minus C squared all over 2AB. So that is going to be inverse cosine of 3 squared plus 5 squared minus 6 squared all over 2 times 3 times 5. 9 plus 25 is 34. 34 minus 36 is negative 2. 2 times 3 times 5 is 30. I get here that angle C is 93.8226 degrees. Would you concur? Now we got to use the law of sines, right? Which angle do we want to find next? Angle. Law of cosines, we find the big one. Law of sines, we find the small one. So we want to find angle A next. So we would say then that the sine of angle C divided by 6 is equal to the sine of angle A divided by 3. So 6 sines of A equals 3 sines of C. So the inverse sine of 3 sines of answer in degrees divided by 6 gives me, I get angle A here as 29.9264. Yes? Then still have 180 degrees in a triangle. approximately 56.25 degrees. Yes, indeedly do. Alright. Example to do after we're done with notes, which will be shortly. We'll talk about that. And shabam. There, we're done. So, what I would like you to do now, because I've been going for almost an hour here. So what I would like you to do now is I would like you to do those examples that we skipped over in this. Okay? And I can put answers up for you on them, or they're up here already for you on them. At Homer's, if you just want to click back in and say, hey, Lynn, what did you get for this one? And I'll tell you what I got for that one, kind of a deal. Okay?